Well, the first thing to understand about model-based systems engineering is it's actually far more of a transition than a transformation. It is about evolving the way that we capture and communicate knowledge. We're moving from low fidelity mechanisms, classic documents or specifications, to higher fidelity mechanisms, and it's enabled by current computer technology. The reason that's important is if we can improve the communication across that team, we can enable better analysis, better connected analysis, but also shared understanding. The reason that's important is the characteristics that we're talking about, things like security, are system level characteristics. They don't come from the pieces alone, they come from the system together. And it has to be designed in from the very beginning as opposed to bolted on at the end. Systems engineering and developing that upfront architecture is your one chance and your one only chance to get that right.
Systems engineering can be defined in multiple ways, as a perspective, process, or a profession. The MBSE Systems Engineering Handbook points to 3 meaningful definitions of systems engineering. A comprehensive definition. Systems engineering is an interdisciplinary approach and means to enable the realization of successful systems. It focuses on defining customer needs and required functionality early in the development cycle, documenting requirements, and then proceeding with design synthesis and system validation while considering the complete problem, operations, cost and schedule, performance, training and support, test, manufacturing, and disposal. Systems engineering integrates all the disciplines and specialty groups into a team effort, forming a structured development process that proceeds from concept to production to operation. Systems engineering considers both the business and technical needs of all customers, with the goal of providing a quality product that meets the user needs. A second definition of systems engineering comes from a 2008 book, Essentials of Project and Systems Engineering Management by Eisner. Systems engineering is an iterative process of top-down synthesis, development, and operation of a real-world system that satisfies, in near optimal manner, the full range of requirements for the system. And from an operational perspective, the third definition comes from the FAA's Systems Engineering Manual. Systems engineering is a discipline that concentrates on the design and application of the whole system as distinct from the parts. It involves looking at a problem in its entirety, taking into account all of the facets and all of the variables, and relating the social to the technical aspect. These 3 definitions all point towards a system thinking mindset, where the focus is on the entirety of a problem and relationships that exist that may impact solutions to the problem. A systems engineering, or SE, process defines the primary activities and methods that make it possible to design and build successful systems, driven by the following key concepts. Success. Success is measured by the ability to meet the needs of customers and users and other stakeholders. System. Defined by the 15288 standard as a combination of interacting elements organized to achieve one or more stated purposes. And finally, the systems engineer. This is a person who supports the approach, translates customer needs into the language of specifications necessary for the system design. For a deeper dive into the definition of systems, take a look at the resources section or the systems engineering body of knowledge.
So MBSE, the International Council on Systems Engineering, is a relatively young professional body. It's about 27 years old at this point. And so it parallels systems engineering in many ways, which is a young practice, not yet a discipline. MBSE is at a very exciting time in its evolution. When I was president, MBSE had long since realized that there are far more people doing systems engineering than ever realize it. Systems engineering as a language grew up in aerospace and defense. As we put a man on the moon, as we put satellites in orbit, as we built high-tech planes, etc., we realized complicatedness and complexity. and systems engineering grew up to deal with that. But at the same time, if you look at the degree of complication and complexity in an automobile, or a medical device, or in the energy industry, or in the enterprise itself, those same issues arise, they're just under different terminology. So INCOSE is at a point in its evolution where it's realizing it's not as much about being evangelical about the practice, that's important, but it's connecting the practice that is going on under so many different names in so many different areas so that we can take the shared experiences from aerospace, from medical, from automotive, from transport, and beyond. Some of the progress made during my time as president was actually meeting with leaders from organizations like Shell and General Motors and Ford and even Schindler Elevators. People who are dealing with complicated problems and complex problems, understanding how they're doing it and sharing experience for how others are doing it. Everybody who recognizes that they're dealing with a systems problem is trying to advance their systems practice because they understand that change is happening faster, technology insertion is happening faster, and a good command of systems engineering is the only way that they can keep pace.